Hello students, this is Karthik, your maths tutor, heartily welcoming you to Vista's Learning. What is Vista's Learning, students? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in today's session, what we are going to do is we are going to start with class 11th mathematical topic, the very first chapter in class 11th, that is sets. Okay. So what are we going to see in today's topics? So this is what we are going to see in today's session. So we are going to start with what are sets, representing sets in different forms, intervals and types of sets. So in this video, so these are the learning outcomes. So at the end of this video, you'll be able to answer all these things. Alright, so let us start with today's class. So the very first question is, students, what is sets? So sets are defined as collection of well-defined objects. Okay. So there is a word here called as well-defined objects. Okay. So there is a word here which is well-defined object. So what is the meaning of this word? What is the meaning of well-defined objects? So students, well-defined is those objects, okay, which does not change from one person to another person. So for example, I've presented few examples here. So from the following, which of them are sets? So understand what is sets. Sets is defined as collection of well-defined objects. And what is the meaning of well-defined objects? It does not change from one person to another person. Okay. So let us see this very first one. Days of a week starting with the letter S. So will this change from one person to another person? I don't think so. So what are those days in a week which start with the letter S? Obviously that is Saturday and Sunday, weekends, Saturday and Sunday. So this does not change from one person to another person. So the very first example is defined as a set. Alright, we'll go to the next one. Months in a year starting with the letter J. So how many months are there in a year starting with the letter J? So there are 3 months, correct? What are those months? January, July and June. So again, this does not change from one person to another person. So B is also a well-defined set. So well-defined, that is well-defined object, so it is called as a set. Okay, let's see the next example now. Best fruit juice. So fruit juice, students. So there are many fruits, as you know. So is that a set? Because few people like sapota juice, few people like apple juice and few people like mango juice. So this changes from one person to another person. Alright, so is this a set? Okay, this is not a set. Okay, so this is a set, this is also a set. We'll go to the next one, best movies. So just you can inquire your friends, which is the best movie you have watched. So the answers will differ from one person to another person. So it is not a set. So did you understand what is sets? So sets are nothing but a collection of well-defined objects. What is well-defined again? Well-defined means it does not change from one person to another person. Okay. Moving on to the next one. Representation of sets. So then how can we represent sets? So we know that now what are sets? So it is a collection of well-defined objects. Now how do we represent sets? So we can represent sets in two different forms. What are those forms? The first one is the roster or tabular form and the second one is set builder form. Students, one thing you have to keep in your mind while representing sets. So for example, months starting in a year or months in a year starting with the letter J. How do you write this? So it should not be written like this. So A is equal to January, July and June. So this is correct. Okay, these are the months in a year starting with the letter J. But always remember one thing. Whenever you are representing a set, okay, you must enclose those elements with the help of the braces, or these are also called as flower brackets. So if you are enclosing the elements within these braces or the flower brackets, then it is considered as a set. If you simply write January, July and June, then those are only the elements. It is not called as a set. Always remember, to represent set, you have to enclose those elements within the braces. So what are these both forms, roster form and tabular form? See, roster form means another example we'll take. So here we'll take an example of multiples of 2. Multiples of 2. So how do we write this? So this can be written as 2, 4, 6, 8, 10. So let us stop that here. So these are the multiples of 2. In which form have I represented this set? So let us call this as set A. Alright. So these multiples of 2 which is represented by set A is written in which form? It is written in roster or tabular form. Understood? Now you have to represent a set in another form. Which is that form? It is called as a set builder form. So the same set, okay, if you have to write it in a set builder form, how would you write it? So it is like this, students. In set builder form, let us take B only. So B will be equal to 2n such that so it is overlapping here. So B is equal to 2n such that n is equal to or greater than 1, but n is lesser than or equal to 5. So what are the values of n then? So n can be equal to 1, 2, 3, 4 and 5. Correct? So these will be the possible values of n. So in the place of n put 1, what will you get? You will get 2. In the place of n put 2 again, what will you get? You will get 4. In the place of n put 3, what will you get? You will get 6. In the place of n put 4, you will get 8. And in the place of n you can put 5 again. So you will be getting 10. So did you understand what is happening here, students? We'll just erase that. So what is the meaning of roster or tabular form? Listing down the elements itself. For example, multiples of 2 means 2, 4, 6, 8, 10. So that is nothing but roster or tabular form. What is set builder form? Okay, you have to, same elements only you have to represent, but not listing down the elements. Okay, with some operations like this. So B equals 2n such that n is greater than or equal to 1 but lesser than or equal to 5. This is how you have to represent a set in a set builder form. So two ways to represent sets. Set builder form and roster form. Another very important thing, whenever you are representing a set, always remember it must be enclosed within the braces. Then it will be considered as a set. I hope you are clear with this. We'll go to the next slide. So that is points to be noted or symbols or notations used in sets. So what are the points to be noted? So I think you know some of them. So what does capital N stand for? Set of natural numbers. Capital Z, set of all integers. Capital Q, set of all rational numbers. Capital R, set of all real numbers. Okay, further, Z to the power of plus, it is like this. Z to the power of plus means what? Set of positive integers. Only positive integers are considered. Z to the power of minus, like the students, Z to the power of minus means what? Set of negative integers. All the negative numbers are included. See this symbol, students. Okay, this symbol, I'll just draw that once again. The symbol is drawn like this. Okay, put a C and put a straight line in between that. This symbol is derived from Greek. And what does that mean? It means epsilon. In this chapter of sets, whenever you see the symbol epsilon, you have to read it as belongs to. Okay, what does epsilon mean? Epsilon mean it belongs to. So for example, I'll tell you. For example, A is equal to 1, 2, 3. Now here the question is, 2 belongs to A, true or false? 2 belongs to A, true or false? Can you find out 2 in A? Yes, we can find out. So 2 belongs to A, whether it is true or false now? It is true. Understood? Means belongs to means whether that particular element is in the set or not. So that is nothing but belongs to. And what is this, students? The very last thing here. Okay, it is a semicolon like this. Semicolon. And how do you read this? You must read this as such that. Okay, another example for such that, okay, so on the screen. So let us take A is equal to x such that x belongs to n and n is lesser than or equal to 10. I have written a set on the board and it is in which form? Yeah, this is in the set builder form. Can you convert the set builder form into the roster form? Okay, we'll just try. A will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is in which form now, students? Roster form. Okay, this is in which form? Set builder. Alright. So these are the points to be noted down. So you can just make a note down in your book. We'll move on to the next slide. Alright. So the next one, what we are going to start with, same thing, whatever we have seen previously, set builder form and the roster or tabular. So I've given few examples here. So set builder form, the example here is x such that x is a natural number less than 6. So previously we saw less than 10, right? So obviously you can write this. So this is in the set builder form, students. How do you convert it into the roster form? So in the roster form you can write it like this. B equals 1, 2, 3, 4, 5 and 6. Correct? See, set builder form it is written x such that x is a natural number and it is lesser than 6. Okay, less than 6 means the 6 will not come only until 5. Okay, less than 6 means 1, 2, 3, 4, 5. Alright. Next what we have, roster or tabular form. So this set, let us consider this as A. Okay, so set A is written as what? 2, 4, 6, 8, 16 and 32. This is in roster form. We'll try to convert this into a set builder form. How to do that? So see the students. 2 to the power of 1 is nothing but 2 only, correct? 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16 and 2 to the power of 5 is 32. Right? Geometric progression. So we'll be seeing what is geometric progression as well. So let us take it as A1. So now it is in roster form, right? See, this is in roster form. We'll try to convert it to set builder form. So we will write A will be equal to x such that x is equal to 2 to the power of n, comma, where n is equal to or greater than 1 but lesser than or equal to 5. This is the set builder form of the given roster form. And this is the roster form of the given set builder form. Understood, students? So roster form means what? Just listing down the elements. Set builder form means same thing, but you are writing it with the help of some variables, symbols and some inequalities. Okay, so this is the two ways of representing sets. One is in the roster form, one more is in tabular form. Sorry, roster form and one more is in set builder. We'll go on to the next slide. Okay, next we are going to see is intervals. So what are intervals? Okay, we are going to see that now. So on my left side there are few images coming up. The very first thing is an open interval. So students, I think you can see this. Okay, you can also make out difference. So this is a black line here. Okay, this is a blue line and there is a black line again. Now what is an open interval, students? Open interval and closed interval. First of all, we'll see what is the meaning of interval. Interval means a range of values. Okay, that is called as an interval. And in intervals we have two types. One is open interval and one more is closed interval. How do you represent open interval? Open interval can be represented like this with the curled brackets. Open interval. And how do we represent closed interval? Closed interval can be represented like this with the square brackets. What does open interval mean? Means values are not included. Values are not included. I'll explain you, students. And what does the closed interval means? This means values are included. Values are included. Okay, so I'll explain you both of them. You can just make a note of this. Okay, now we'll go to the left side of the board. Now see here. Let us assume some values for A and B. Alright. So we'll just clear the board once. So let A is equal to, let us take some 4. Okay. And let B is equal to 7 we'll take. Understood? Let A is equal to 4 and B is equal to 7. And what are we discussing right now? Right now we are discussing open intervals. How do you represent this open intervals now? So since it is open interval, we'll be representing it as curled bracket 4 comma 7. A curved bracket 4 comma 7. Now what is x, students? So just make some difference with the colors here. See, this is x, this blue color line, whatever you can see here. So this entire thing is x. Okay, not including the dots. Okay, no dots included. That is why we have used what? Curled brackets there, curved bracket. Okay, so this is open interval, means x can be what? So in the place of a, what can we write again? 4. Same inequality, x as it is. And again, in the place of b, we can write 7. So now what are the values of x, students? So x can be equal to 5, x can be equal to 6. That's it. Correct? Means x can take these both values. X can take the value of 5, x can take the value of 6. But x cannot take the value of 4. Why? Because it is an open interval. X cannot take the value of 7. Why? Because it is an open interval. Understood? Open interval. So x is equal to, so 5 comma 6, these both are the values of x. But how to represent this interval? Open interval, curved bracket 4 comma 7. Whenever you see curved brackets on both the sides, so curved bracket on the left side, right? Eliminate 4. You should not take 4. Do not include 4. On the right side also you have the curved bracket. Eliminate 7. Do not take 7. What is in between 4 and 7? 5 and 6. Means x can take the values of 5 and 6 only. It will not take the values of 4 and 7. Understood? We'll go to the next one. Closed interval. Now you see, the blue thing is starting from here. Correct? Here also the blue thing is starting from here. Previously the blue thing was starting from here. Okay, not from here. It was starting from here and it was ending at here. Now you see the blue thing is starting from here and ending at here. Same example we'll take. Let a is equal to 4 and b is equal to 7. Alright. So once we take a is equal to 4 and b is equal to 7, see the inequality what is written here. A, x and b. So we'll just substitute the numbers there. 4, x and 7. Now what is x equal to then? X will be equal to, x is greater than or equal to 4. So we are including the value of 4, right? So let us write 4, 5, 6, 7. Why we are writing 7 also? X is lesser than or equal to 7. So now how do you represent this interval? Square bracket 4 comma 7. Which means what, students? We can include the number 4, we can also include the number 7, and we can also include the numbers in between 4 and 7. So that is 5 and 6. This example, the very first example, how do we write? 4 comma 7. We cannot include 4, we cannot include 7, but we can include the numbers between 4 and 7. So that is 5 and 6. Understood, students? So this is the difference between open interval and closed interval. Open interval are represented by curved brackets. Closed intervals are represented by square brackets. Okay, we'll move on to the next slide. Continuation of intervals only. So, but this is semi-open interval and semi-open interval again. Alright. So see here. See this and see the colors. X is greater than or equal to A. So the color is starting from here, but the color is ending here. Correct? Same thing here. The color is starting from here, but the color is ending here. So how do we represent this? So let us assume some more values. So this time we'll take this as 11, and this we will take it as 17. Are we including 11? See, the color is starting from this point itself. Are we including 11? Yes, we are including 11. So how do you represent that? Square bracket 11, comma. Are we including 17? So 17 we are not including because the color is stopping there. 17 with the curved bracket. So what do you understand when you see it like this? 11 is included, but 17 is not included, and the values between 11 and 17 are, okay, we can consider those values. We can include those values as well. Same thing here. So x greater than a but lesser than or equal to b. How to write this? So let us take it as 11 only. Let us take it as 17. So we are not including 11, see, because the color is starting from here. So curved bracket 11 comma 17 with the square bracket. Means this time we are including 17, but we are not including 11. And the values between 11 and 17, okay, we can consider them. So this is all about intervals. Once I'll give a very quick summary on this side. Open intervals are represented by curved brackets like this. Closed intervals are represented by square brackets like this. Okay. So open interval, any number, for example 4 comma 7. Okay, 4 is not included, 7 is also not included. In between values are included, that is nothing but 5 and 6. That's it. So if suppose I write it like this, 4 comma 7, 4 is also included. Okay, 4 is included, 7 is also included. In between values are also included, that is 4, 5, 6 and 7. Okay, on this side I have already explained. Semi-open interval. Okay, so for example 11 comma 17. So 11 is included, 17 is not. In between values are included. Same thing here, 11 comma 17. So this time 17 is included, 11 is not included. In between values are included again. Understood? So this is all about intervals. We'll move on to the next slide. Types of sets. So what are the types of sets? So as you can see on the screen, the very first set is called as null set or empty set. So what is null set, students? Null set is nothing but, so here you can see, it is empty. Means there are no elements inside a null set. How do we represent null set? So null set can be represented like this, phi, or it can also be represented with just two braces, and there are no elements inside this. So this is called as what? This is called as a null set. Next, what do we have? Singleton set, which means, for example, 1, which is having only one element inside it, no more elements, only one element. So that element, that set is called as what? Singleton set. Finite and infinite sets. So the names are only suggesting what are finite and infinite sets. What is finite set, students? So if in a set there are countable number of elements, then that particular set is called as a finite set. If in a set there are infinite number of elements, means uncountable number of elements, then it is called as an infinite set. So let us take an example and understand them. Finite set, for example. So let us take an example of finite set. Number of animals, okay, number of animals on this planet. Number of animals on this planet. So there are many animals, many countries, okay. So, but you can count them, right? It is not infinite, it is countable. So that is called as what? A finite set. An example for infinite set. Positive integers more than 100. So what are the positive integers more than 100? 101, 102, 103, 104. It goes on. Where is it ending? So does number have any end? Numbers do not have any end. So this is an example of what? An infinite set. So these are the different types of sets. Okay, so this is not completed, students. So there are some more types of sets, okay, which we'll be studying in the next class. Okay, so once again summarizing whatever we have seen today. So basically we started with what is set, how to represent a set, what are intervals, different types of intervals, how to represent intervals, closed intervals and open intervals, and finally we saw what are different types of sets. So this is all for in today's session. In the next session we'll be continuing with the types of sets. Okay, I have left out equivalent set, one more set. So what is the meaning of equivalent set? Students, very simple. So let us take two sets here. Let A is equal to ABCD. Okay. And let B is equal to alpha, beta, gamma, delta. Okay. So now students, how many elements are there in set A? 1, 2, 3, 4. So how do we write this? N of A is equal to 4. What is this N of A means? Number of elements in set A. How many are there? 4. Understood. Next, N of B will be how much? Count the number of elements. 1, 2, 3, 4. 4. What can we tell now? N of A is equal to N of B. Means the number of elements in set A is equal to the number of elements in set B. So whenever two sets have same number of elements, then those both sets are called as what? Those both sets are called as equivalent set. So just remember this. If N of A is equal to N of B, then those sets A and B are called as equivalent sets. So we have studied some 5 different kinds of sets. 1, 2, 3, 4, 5. Okay, this will continue in the next class again. So for this session, we are going to stop here. Subscribe to Vista's Learning. Stay connected with us. Okay, we'll make math as simple as possible for you and you can score very, very well in your examinations.